Hello friends, welcome back to our YouTube channel. In this video, I would be explaining you how you can design a RCC slab in Staad Pro using plate elements. In this video, I would be covering three methods by which you can analyze and design a slab in Staad Pro. First method is your conventional method or the most widely used method in industry in which you can you can analyze your slab. In this method, you will be analyzing your slab, then you will extract your forces mx, my and mxy from your model, and then using a simple spreadsheet or Excel sheet, you can design a slab by this method. Now the second method is by using a design command and then getting reinforcement from the output file. Okay. Now the third method is to use a add-on in StatPro, that is advanced slab design, by which you can design your slab. Okay, so friends, let's start generating a simple stat model using plate elements. Now we will start with new project, selecting space and our unit systems. Then we will add beam. Through add beam, I will be generating a model. I can also select by add plates. Okay, so by add beams I can generate a model. Now it will land up to our default grid window. Now I will be changing my grid system from XY plane to XZ plane. Okay, now I will be making a line element that is the outer boundary of the slab. Okay, so this is my this is the outer boundary of the slab which I have to design, but these are beam elements or line elements we can say. But since we have to design a slab using plate elements, so I would be modeling a plate here. Okay, now you can see that I will be selecting plate cursor. So this is my plate, right? I would be deleting the beams that I have modeled because I don't require them. So this is my plate. Okay, you can view it if you do control 3, then you can view it. This is my plate. This is the bottom of the plate. This is the top of the plate, right? Green is top and blue is bottom. If I do shift T, then this is my plate axis, which is different from the global axis that Staad is having. So this is my Y plane. This is my X plane of plate. So I would be getting moment XX like this and moment MYY like this. And the resultant, or we can say torsional moment, will be MXY. So again shift T, it will go control 0. If I do control 0, then it will go. Now I modeled a plate, but this plate is very big. The size is 10 by 10 meter. So I will mesh it. Okay. So I will do the right click and select generate plate mesh. This I would be selecting quadrilateral meshing because it will give us rectangular plates. Okay, 4 quads we can say. So this is the A, B, C, D. Okay, it is like this: A, B, C, D. So I would, let's say I would be dividing it into 10 portions. So I will write 10 here, then again 10 here, 10 here, 10 here. I can change this one also. Suppose if I do 5, then it will automatically divide. This edge, there will be 5 fragments. Okay, since I have divided this AB into 5, I will apply it. So see, 1, 2, 3, 4, 5. In this also 5. We can change it according to our meshing, whatever how much finite mesh we want. As per our meshing, we can change our quadrilateral sizes. Okay, so this is the final slab geometry that we have made. Now what we will do, we will come to our we will come to assigning property. So here I would be assigning property of 200 mm thick. So I would be going to thickness. Plates are assigned from thickness. Okay, okay, 0.2. Then concrete, I'll add it. Then I will assign it. Okay, so it is assigned. You can see the 3D of it. It is like this. It is pink in color, while beams are blue in cyan in color. We can say cyan or blue, whatever color you can say. Mm, so we have assigned a property to our elements. Now we will go to support. I'll okay. Now we'll go to support. I'll create fixed support. Let's assume that this slab is fixed from all sides. Okay, slab is fixed from all sides. So I'll assign it to the selected nodes. Okay, the nodes are gone. See, I've assigned the supports. Now what I will do, my supports are finished, my property is finished. I will go to loading. I'll add loading. Okay, add. Then what I will do, I'll go to, I can also use floor load, but since plate is there, I will be using plate load. You can also provide some nodal loads if you have any node vertical point load is there over your plate or over your slab, then you can use nodal load also. Suppose let's see minus 10 we have nodal load, and I will be putting another plate load of minus 5. Okay, in GY. Then what, one more thing is there, self weight. I'll add the self weight. So minus 10 is, let's say I put it here. I'll assign it. Then it will be like this. Okay, this 5. Select the plate. I'll select full plates. I'll be assigning this 5 here. See, it has been assigned to whole plates. Then self weight. I can select on full view. Okay, now all the loads are assigned. You can see. Now what I will do, I'll be my loads are finished. Now I'll be running my model. So I'll add perform analysis. Okay, I'll do the run analysis. So you can see our model is run without any error and warnings. So I'll go to post processing. You can see this is our model and this is our post processing. So what I have to see is the movements, right, in X and Z direction. So shift T. So this is my Y, this is my X, this is my Y, this is my X, this is my Z. Positive Z means top bar. If I got positive value of X or Y, then the reinforcement will be in top, and if I got negative value in of moment in X and Y direction, then the reinforcement will be in bottom. Okay, let us see now what will be our moment. So I'll go to this plate stress tool, then I will be selecting MX. So this is the negative moment in X direction. MX will be like this. Okay, moment is like this, MX moment about X axis. So negative 20 and positive 18. I'll apply it. So you can see here, I got the contour map. This is called contour map of plates. See, this is 18, this is minus 20. brown portion is minus 20. Okay, so 18 means positive, means here there is top reinforcement. Okay, since there is hogging moment here, and you can see minus 20 here, there is sagging moment here, so the reinforcement here will be in bottom. So similarly you can see for my, you can see for my, then again for 1000 also you can see mxy. This is a 1000 moments, 1000 moment. Now what you can do is, this is one method. Now what in the beginning I've told you that this is the most common method that is widely used in industries. Okay, so in this method we have completed our analysis. Now what we have to do, we have to extract our forces from what we can do. What For extracting our forces, we'll go to report. We will be selecting plate stresses. I didn't select the plates, so I will be selecting plates. Okay, report plate stresses. These are the shear, SQX, SQY, and membrane stresses, and these are the bending stresses. Okay, loading is 1 since we have only one load. So this is the table that we got. We can copy it in our Excel sheet and design our slab using our spreadsheets. Okay, this is one method with which we can design our slab. Now let us come to our second method. Second method, up to analysis, it is same. Okay, now what we will do, what we will do, we will use a design command. Okay, we'll go to concrete. I'll give a comparison in this. I will give a comparison of two codes, IS456 and BS8007. Okay, so I will be selecting IS456. This is our Indian code, and I will be defining the parameters. What I need, clear cover. Let's say it is 25 mm. Add it. Grade of concrete is 30. Add it. Fi main is 500. Add it. Okay, we don't need anything else. Now I'll go to command. Since we have to design an element, I will be selecting design element, and I would be selecting takeoff. I will add both these. So these are the parameters that we will be using for designing of slab as by using IS456. I'll assign to view. Similarly, I'll be selecting another code. I'll select BS8007. Okay, now I'll be again define parameters. Suppose clear cover is same, 25. I'll add it. Crack, as per codal provisions, you can provide crack here, but we haven't provided crack in IS456, so we will not be providing this one. So grade of concrete, same 30. I'll add it. And then Fy 500. I'll add it. Okay, now I'll use command design elements and take off. I'll add this. So I'll assign this to my plates. So I've assigned all the things to my plate. Now let us run the analysis again. So this I have given you a comparison of two codes. So I will go to output file directly. Okay. So this is the design as per our Indian code IS456. You can see this is the elements number. We have different elements. This is the top reinforcement. This is the bottom reinforcement. Okay. You can see this is the moment is there, MX is there, MY is there. Longitudinal reinforcement, transverse reinforcement. Similarly, we can go to BS8007. these are the elements. It is little bit detailed in comparison to our code. Okay, this is BS8007. So in this case also, this is giving MX top, MX bottom, MY top, MY bottom. Okay, at different spacing, it is giving the reinforcement. What is the AST required? What is the AST provided by StatPro? Similarly, for different bar, it is giving. Okay, design is for various all the elements it is providing. So this is the second step we have completed by designing the elements using StatPro. Now there is one more method by which we can design our slab. It has some limitations. All the codes are not listed in this method, but we can do a rough check of our slab. Okay, so this is the method. This is this advanced slab design. We'll go to advanced slab design. I'll do shift T. Okay, this is the advanced slab design. Now what I will be doing, I'll go to result, slab reinforcement. So there are only two codes. One is BS and other is NS. Okay, I'll be selecting BS. So our cover is 25. Okay, top and bottom. This is wood armor method. If we want to add MXY to our moments MY and MX, then I would be considering this one also. So now other thing is their material. Material, which grade of concrete you want to use? It has different grade of concrete. I'll do user specific since my grade is 30. Then this is also having grade of concrete. These are as per BS codes. I would be using standard 500. Okay. This is the reinforcement. I can change the reinforcement here, but we will keep it 10 only. So this is the layer orientation, bottom bar and top bar in X direction. This is the X direction. Our reinforcement will be like this, and this is the Z direction as per global coordinate of Staad. Okay, so I'll do normal and I'll go to loading now. I have only one load case. I'll be taking that load case. I'll apply it. So now what reinforcement you need? Top reinforcement in X direction. You want to see top reinforcement in X direction. Now you will go click OK. So this is the contour which shows AST, area of reinforcement required. So this is 245 mm. Here we require 245 mm. I have selected top here. So in top you will be providing 240 more than 245 mm square. Okay. So similarly you can select in Y direction. Bottom also you can select. Bottom reinforcement will be here more. Okay. See, this is the bottom reinforcement. It will be more here because the slab will have more sagging moment here and it will have more hogging moment here. So guys, I've covered three methods by which we can do slab design in StatPro. So with this, I will conclude my topic here. For more videos on StatPro, please go through the link given below in description box. If you do like my videos, please like, share and subscribe. Also hit the bell icon for latest videos. Thank you and goodbye.